In this video, we're going to look at section 1, example 5, understand average rate of change over an interval. So part A, what is the average rate of change of a function y equals f of x over the interval a, b? Now, looks like there's a lot going on here in this little graph chart here, but let's kind of simplify it. Let's break it down and see what information we need. So our interval, we're looking at the graph, so that like red line, we're starting. Let's highlight this. So we're looking to start at this point here, point A, and then we're going up to point B. Right, so our starting point again is A, and then we're going up to B. Now you can kind of follow that dotted purple line, you can follow the curve, but each one of these pieces means something. So our total change, let's write this down. So the total change in this function is this blue section here. All right, FB minus FA. All right, that's our change, our vertical change there, right? So that's the total change, which is f of b minus f of a. Now, the terms might get a little tricky, but at the end, we'll simplify this and hopefully it'll make a lot more sense. And then the length of that change is from a to b, this part here, right? So that's going to be b minus a. That's going to tell us, how far we went, in this case, left to right. So we want the, let's write this, let's go red here. We want the average rate of change. So the average rate of change is going to be the ratio between those two numbers. So as the ratio f of b minus f of a over b minus a. Now that may or may not look familiar to you, all right, that form, but this is our slope, all right? F of b minus f of a, right? Those are my y values, all right? That's here, that's y and y. So what we're really looking at, to simplify this, is we can say y2 minus y1 over x2 minus x1. That b minus a is here, this a, and this b up here. So what I'm doing is the average rate of change is my slope. All right, y2 minus y1, x2 minus x1. So they show all of this, f of b, f of a, they've got this purple dotted line, the blue and green lines. Ultimately, what it comes down to is your average rate of change is the slope between your starting point and your end point, all right, whatever that happens to be. Now, this could vary depending on what the starting end point is, obviously on your graph, but in this case, starting point, end point. Look at the coordinates and then just use your slope formula. So let's take a look at example B and kind of put this into practice. So it says, what do the average rates of change? Again, we're looking at average rates of change over the intervals -2, 0, 0, 3, and -2, 3 indicate about the given function. So what they're looking for here is kind of three different parts. So we want to look at -2, 0, 0, 3, and -2, 3. Now, the book isn't very clear about this, but they want each of those three changes, average rates of change, for each of the graphs, this blue one, this red one, and this green one. So my average rate of change between -2, 0, that's not a coordinate point, that's interval notation. So they're looking at -2 here and 0. So these are the 2 points that they're looking at, this one and this one for this specific problem, or this specific part of that problem. So I want to look at these 2 points, -2, 1, and 0, 1 for this. So take your y values. All right, y minus y, which is going to be 1 minus 1, over x minus x, in this case 0 minus negative 2. That's going to give me 0 over 2, which is just 0. So my average rate of change from negative 2 to 0 is 0. All right? It's not going up. It's kind of that simple. Now the next part, it says 0 to 3. So this time we're looking at this point and this point here. So again, y minus y, in this case 1 minus 1, over x minus x, so 3 minus 0. 1 minus 1 would be 0, 3 minus 0 is 3, and then 0 divided by 3 is 0. So my average rate of change here from 0 to 3 is 0. And then finally, they want from negative 2 to 3. So we're looking at the negative 2 1 point and the 3 1 point. Y minus y, 1 minus 1, x minus x, 3 minus negative 2. So we get 0 over 5, which again is 0. All right. So we'll go into the second part where it says, what did the average range indicate? We'll go to that when we compare all three. Let's take a look at the second one here. So from negative 2, 0, we're going to look at this point, negative 2, and then 0, negative 1. I know this is kind of cluttered, but hopefully you can see that. So y values. My y values are negative 1 minus negative 2. Sorry about that. And then that is going to be over. Since I did negative 1 minus negative 2, I must do 0 minus negative 2. So negative 1 minus negative 2 is going to be 1. And then 0 over 0 minus negative 2 is 0 plus 2, which is 2. So we get 1/2. My average rate of change between those 2 points would be 1/2. Let's look at 0, 3. So that would be from this point to this point. Y minus y. So we're going to do 0.5 minus negative 1 over 3 minus 0. So obviously the bottom's going to be a little bit easier. We're going to get 3 there. And then 0.5 minus 1, so that would be 1.5. And then we don't want a decimal in the fraction, so we're going to fix this. 1.5 over 3 is going to be 1/2. And then our final one, we want to go from negative 2 to 3. So here to here. Again, this does get a little tedious, but each problem you're not going to have to do this 3 times for 3 different graphs. So 0.5, or y minus y, 0.5 minus negative 2 over 3 minus negative 2. So my denominator 3 minus negative 2 would be 5. 0.5 minus negative 2 would be 2.5, which again is going to be equal to 1/2. And notice here, my average rate of change all 3 times was 1/2. It's not always going to be the same, but we'll point out why it's the same in a minute. And then finally, let's do this last one. Then we'll get to a little more discussion on what these numbers mean. So negative 2 to 0. Negative 2 to 0. Y minus y would be 0 minus 4 over 0 minus negative 2. I didn't point this out earlier, but notice with the negatives, I'm using a parenthesis. That's so I don't mix up my signs. Just my personal preference. I think it makes your life a little bit easier. 0 minus negative 2 would be 2. And then negative 4 divided by 2 would be negative 2. If you want to write that over 1, you can. The second group, we have 0 to 3. So we're looking from here to here. So I'm going to do 9 minus 0 over 3 minus 0. Oops. So I get 9 over 3, which is going to be equal to 3. Again, if you want to write it as a slope, that's 3 over 1. And then my final grouping, -2 to 3. So from -2 to 3, I'm going to wind up with 9 minus 4 and 3 minus -2. 9 minus 4 is 5, and 3 minus -2 is also 5. So that's going to be 1 or 1 over 1. And again, each time here you're looking for slope. So if you go back up to this green graph here, we're looking for the slope of that line that connects them. All right, so now that we've found the average rates of change, what do these actually mean? Okay. So what does this tell us? What are the average rates of change over the intervals -2, 0, 0, 3, -2, 3 indicate about the given functions? All right, so this first one, my average rate of change is the same, 0, 0, and 0. Since the average rate of change is constant, okay, over every interval, the average rate of change is constant. What that tells me is that I'm going to have some kind of linear function. All right, it's going to be a straight line. Now, in this case, the slope was 0, so it's a horizontal line. All right, so average rate of change is constant. We're going to have a linear function. And if I look at part B, or sorry, not B, this red one here, I have 1/2, 1/2, and 1/2. Now, again, the average rate of change, the average rate of change, I didn't say that on the last one, is constant. Since it's constant, that tells us we have a linear function. So let's say that means it is a linear function. And that can be repeated for the blue one here. So that's going to be a linear function. So the average change is constant. So let's rephrase that. Let's say the this means it is a constant function. So this means it is a constant function. So we're saying it's linear. Okay. So constant function and a linear functional tie-in. Now, this third one, all right, we have -2, 3, and 1. Our slopes are different. All right, so our average rate of change is not constant. So the average rate of change is not constant. What that tells me is this is a nonlinear function. This is a nonlinear function. Now, it's not going to tell me whether it's a parabola. It's not going to tell me if it's a cubic, if it's a quadratic, but what it does tell me is that it's not going to be a line. So if your average rate of change varies throughout your graph, it's a nonlinear function. And in the blue and red one, where it was constant, then you will have a linear function. So it seems like a lot, it seems kind of drawn out, but ultimately what you're looking for, the average rate of change, just remember that's the slope. Okay, so you're looking for the slope between the 2 points of whatever the graph happens to be. So give the try it example, try that one and see how it goes, and then we'll get to that in another video.